Hey, mathletes. What we're going to take a look at in this video is we're going to look at the released items for the Math 30-1 January 2019 diploma. So it's actually an entire diploma that we're going to go through here. If you don't have this file, just go to the Googles and Google up Math 30-1 January 2019 diploma, and it will pop up as a PDF for you. Okay, the other things I want you to make sure you have with you, you need your formula sheet, of course, and a graphing calculator, and a coffee or a tea, and we will work through this thing. Okay, as you go through it, friends, here's the answer key. And what this tells you here is the diff is what it's called, is the difficulty. So it tells you what percentage of students in the province got this correct. It tells you the answer, tells you the topic from the program of studies. I don't know if you care too much about that. And the cognitive level, again, I don't think you care too much about that. All right. So what I really want you to do, friends, there's the written response as well, and we'll talk about the written response, and I'll give you some hints to do really well and maximize your score on the written response. What I really want you to do, though, is to try each question on your own. So pause the video, try it, and then unpause it and see how you did compared to me. All right, so here's your first one. Hit pause, and then come back and see how you did. Okay, let's see how you did. So we got this 0.38 on an exponential function where b is bigger than 1. So all that's telling me is that this thing is increasing. All right, so it says, what is the corresponding point p prime on this new graph? Well, the first thing I'm going to do, friends, is I'm going to isolate for y. I like to do that. And describe the transformations to myself. Okay, this is horizontally translated 1 unit left, vertically translated 3 units down. I'm going to make my map. So x, y, 1 unit left, 3 units down. Now, once I've got that map, friends, all I've got to do is just sub in this point. And guess what I'm going to get? 2, 5. There it is, your first diploma question. Okay, so your diploma always begins with transformations. It's usually the first 5 or 6 questions. Okay, question number 2. What they give us here is they give us the function f at x, and they give us the domain of it, and they give us the range. And they say the function undergoes this transformation. Okay, we got to find the new domain and range of the transformed function. Okay, first thing I'm going to do, friends, is I'm going to describe the transformations to myself. So I'm going to use abbreviations here. Don't use abbreviations on the written portion of your diploma. You will not get full marks. Abbreviations here is okay because no one's grading it. They're only grading A, B, C, D, right? Remember, this is a horizontal stretch by the reciprocal 2/1. And this is a vertical reflection about the x-axis. Okay, now that I know that, friends, again, I'm a big fan of making my map. So xy is going to go and become 2x, negative y. Now all I'm going to do is I'm going to find out what my new domain is. Well, x, if I sub in 2 times x is 4. And if I sub in 6, 2 times 6 is 12. And guess what? Right off the bat, I can see that's answer D. What I would still do is check my range. So I sub in -4 and 8. Well, -4 is going to become +4. Positive 8 is going to become -8, and they switched orders because it's a reflection. So the bounds switch sides, right? Okay, hey, not too bad, right? 2 questions in, not too bad. Okay, this one here says we've got f at x, and we're going to transform it into g at x, and we've got to figure out the new equation. Okay, I'm always going to look at the answers, and it gives me a bit of a hint as to what I'm looking for. Okay, I'm definitely going to have a horizontal stretch. Maybe I've got a vertical stretch. Maybe I've got a vertical translation. All right. Well, how I'm going to attack this is I'm going to look at my original, and I'm going to say, originally, what is that? That looks like it's 20 wide. And how high am I? Well, I'm 10 high. Okay, that's the original. That's f at x. Then what I'm going to do is the same thing for g at x. I'm going to say, how wide is g at x? Well, g at x is 40 units wide. and g at x is 20 units high. So what were my transformations then? Well, I can tell this thing hasn't been reflected and I didn't see any reflections in my answer. So what I'm going to say to myself then is if I was 20 wide and now I'm 40 wide, I was horizontally stretched by a factor of 2. And if I was 10 high and now I'm 20 high, I'm going to vertically stretch by a factor of 2. Now, where the answer goes wrong here is a lot of students go, oh, look at that. Boom, 2 and 2. No. That's wrong. What you need to remember, we've already seen this once, friends, is that when we want a horizontal stretch, we have to take the reciprocal. That right there is a horizontal stretch by a factor of 2 about the y-axis. Okay, so you got to be a little careful when you're doing those horizontal stretches. We've already seen it twice on this diploma. All right, we got another one. The point A is on the graph of y equals f at x. The corresponding image point, A prime, is on the graph of y is equal to blah, 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 all this other stuff, right? Okay, so first thing I'm going to do is I'm going to factor, right? If I'm not factoring, that's a problem. And then what I'm going to do, again, I like to make my map and describe my transformations to myself. So vertical stretch by a half, horizontal stretch by a third, translated 4 units left horizontally, vertically translated 1 unit down. And then friends, again, here we go. We just sub in our point, right? And when we sub that in, what we're going to get is that'll be -5. And when I sub in 4 here, that's 2, that's 1. There it is. Okay, so again, it's just important here, transformations, you're factoring, you're describing those transformations to yourself, all that good stuff. All right, what do we got here? The graph of some polynomial, f at x, and we want the number of invariant points when the graph of y equals f at x is reflected in the line y equals x. Okay, what is this? This is an inverse. That's what that's trying to tell you. This is an inverse. So what I always want you to do on an inverse is draw in that line y equals x. So remember, y equals x goes through 0, 0, 1, 1, -1, 1, -2, 2. Pull out your ruler, draw it. Any place your graph intersects the line y equals x is an inverse. Or sorry, is an invariant is what I meant to say. Not enough coffee. Intersects twice. There it is, 2 invariant points, my friends. All right, not bad. Now, number 6 is another inverse question. What this one says is a restriction on the domain of the graph so that this quadratic is inverse is always a function. Okay, what does that mean? Well, this graph here is a parabola. And we don't know if it's really opening up or opening down. It doesn't tell us much about it, but what you can kind of envision is you've got a parabola here with a vertex of CD. Well, this inverse, the inverse of f at x, is not a function because it fails the horizontal line test. Remember, the horizontal line test tells us if the inverse is a function. Inverse of this is not a function. That horizontal line crosses the graph more than once. So what we're going to do then is we need to essentially envision kind of cutting our graph into parts so that this horizontal line only cuts it once. Well, if you can see here, if you could envision that this half of the graph was gone, now that horizontal line's only going to cross the graph once. So that would be this domain right there. Now, speaking of domain, on a written question, friends, I need you to write it properly, like this, for full marks. If you write it like it was written here in the answers, you will not receive full marks on your written question. Likewise, friends, you could write it like that. Okay, so the horizontal line test, we've seen that over the last few years, restricting a domain so that the inverse is a function. Okay, so make sure that you've got that little idea figured out. All right, here we go again. Given the function f at x and it's some exponential, it says the y-intercept on the inverse. Well, I don't want to find the equation of the inverse. What I'm going to say to myself, if I want the y-intercept on the inverse, that's the same as finding the x-intercept on f at x. Well, how do I find the x-intercept on f at x? I simply let y is equal to 0. So I let y is equal to 0. And because we're to the nearest hundredth, we'll need our calculator here. So add 16, divide by 4, right? Okay, my unknowns inside my logarithm, or sorry, my unknowns inside my is my exponential. So I'm going to convert to a logarithm. So remember what we end up with here. X is equal to log base 1/3 of 4. If you've got a TI-84, you could just put that in your log base button. If you've got a Casio or a TI-83 that doesn't have that log base button, you need to use change of base. And if you go ahead and sub that into your calculator, you're going to get A. Okay, there we are, friends. Cooking along. Look at that. We're already 7 questions in. We're doing pretty good. All right. Now, what we get here, we get ourselves a log mixed with trigonometry. Who's the person who did this, right? Like, why do we have this possible thing? So when we look at this, we kind of go, ooh, geez, like what's going on here, right? Well, don't panic, right? Just say to yourself, okay, we got this k here, log base 2 of k is equal to 1/2. Cosecant theta is equal to k. And we got a domain and we got to find theta. Well, I can't find theta unless I know k. So I go back to this logarithm and I say to myself, well, how can I isolate for k? Well, I'm going to unknowns inside my log, convert it to an exponential, and 2 to the power of 1/2 is √2. Okay, what does that help me with? Well, cosecant theta is equal to k, so cosecant theta is equal to √2. I don't like working with cosecants, so sine theta is 1 over √2, which is the same as √2/2. So now I think to myself, I'm going to go to my unit circle or my special triangles, whatever makes you happy. I'm going to think of my cast law, and it tells me that I'm in quadrants 2 or 3 based on the domain here, but we've got sine is positive, so really we're looking right here. √2/2 tells me I've got a reference angle of 45, so that tells me that theta is right there. Theta has to be 135 degrees. There it is, friends. Okay, so when you see the log and you see the trig mixed together, I mean, I know I'd be like, oh goodness, why are they doing this to me? But just take it slow, go piece by piece, and you'll usually work your way through the question. Okay, this nasty looking log question. These puzzle questions is how I describe these things. So what we need to do is we need to get these 3 logarithms into this. That's how I describe it. Now, there's more than one way to do this, but what I'm going to do is I'm going to expand log base 3 of 100 m to the 4. And what I'm going to do is I'm just going to go nice and slow. And I'm going to say to myself, well, I know in logarithms, when 2 things are multiplied together, they can be converted into addition, right? Now, I'm starting to get close. I see I've got M4. I need M2 here. And I need this arguments of 5 and 4 in here. So what I'm going to do is I'm going to split 100 up. Well, I recognize 100 is really 25 times 4, right? And even better, friends, what I recognize then is 25 is really 5 squared. So all I just did was converted 100 into 5 squared times 4 so that I can get what I'm looking for in my hints as I've described them. Now, again, I'm going to expand. And as I expand, I'm also going to take my powers and I'm going to turn them into coefficients using my power law. And same thing here. Okay. And now, friends, we're almost there because this first one is 3y at the top right there. So it's 2 times 3y. Log base 3 of 4. Well, that's 2x right here. Now, what this says is log base 3m squared is equal to 6. So what I'll just do off to the side here is I'm just going to, again, take my power law like that and divide both sides by 2, and I get 3. And so now what I can go and do is sub that into here, and bada bing, bada boom, I'm going to see the answer is B. So I think the important part of these questions is making sure that you switch your power to become your coefficient before you start doing substitutions, okay? If you didn't do that, you would probably get the wrong answer of D. All right, number 9. Okay, here we go. Another one of these questions. So what I'm going to say to myself is written as a single log. All right, well, written as a single log. Well, to write things as a single log, the first thing I'm going to do is that coefficient of 4 has to become my exponent or my power. And now what's really sneaky here, friends, is we got to write this as a single log. So what I'm going to do, which is super sneaky, is I'm going to write log base a of a, because log base a of a is 1. And I need that log in there to simplify this. Now what I'm going to do again is I'm just going to take my time with this. I'm just going to simplify again that power of 4 here. So it becomes A4C4 log A4. And now I combine using my laws of logarithms. So if it's addition, it turns into multiplication. So I multiply these together. And if it's division, if it's subtraction, it's division. And I can see that my A4s divide out. And guess what? I see answer C right there. Okay, so I think the sneaky part of that one was converting that -4 into log base a of a, right? That's not always the most obvious thing to do, but that's a little factoid that you need to know. Okay, let's try another one. Probably still in logs. Sure we are. Look at that. So the graph of some logarithms there, shown below, passes through these 2 points. We've got to find the value of the base B. Okay, well, I don't know what to do, right? I'm stuck. So, okay, what could I do? Because I've got to find this B, but I've also got the C. Well, what I say to myself, if I got 2 unknowns, I better have 2 equations, right? Maybe. Thankfully, they gave me 2 points. So what I'm going to do first is I'm going to find that base. Okay, how do I find that base? Well, let's go and just start solving. I don't know what to do. Let's just start solving. All right, I don't know. Let's just sub in. Doesn't matter which point you want to sub in first. We'll sub in 0, 0. We'll see what happens. So if we sub in 0, 0, I get 0 plus C. I get log base B of C. Well, what is this? Converted to an exponential, that's B to the 0 is C. Well, that means C is 1. Oh, that's good news, because now we've got 1 less unknown. We're here. And now to find that value of the base, that's where I'm going to sub in this secondary point right here, like that. And I'm just going to start solving for that base value. Well, that's 3/2 plus 1 is 5/2. And now what have I got? I've got to switch it to an exponential. So B to the 1/2 is equal to 5/2, right? Square both sides, because the squaring and the square rooting are inverses. That's 25/4. And I believe if you put that into your calculator, you should get 6.25. So the value to the nearest hundredth, 6.25. Okay, so again, if you got 2 unknowns like we do here in B and C, you're going to have to sub in 2 points. All right, logarithms, hey? Good times with logs. Ooh, look at this nasty guy. Given y is equal to that mess, and log a to the y, a of y is equal to x, where a is bigger than 1, the value of x is. Okie dokie. Well, I don't know. I've got to solve for x. So what I'm going to say to myself is, let's pick this. Let's rearrange this. So a to the x is equal to y. Well, now, friends, what I say is, look at this. I'm going to sub that into this equation. y is a to the x. And now I think I'm doing this correctly because I see everything's in terms of x, and I see lots of a's flying around. So now all I'm going to do is I'm going to multiply. I like to get rid of my fractions. There's more than one way to do this, friends. But what I'm going to do is I'm just going to multiply both sides by a to the power 2 to the x minus 6. Now divide both sides by a to the x. And what do we get there? Now we're at a 1. Well, really, friends, I'm just going to say this. Well, that's really a to the power 0, isn't it? Right? Because that's 1. And now if my bases are the same, therefore my exponents are equal. And I solve and I get a value of 3. There it is. Okay, so they gave us a couple functions. So we do a system and we do some substitutions. Not awful, not awful. Just lots of algebra at the end. Okay, what do we got here? Sip some coffee first. Joe invested all this money at a fixed annual interest rate, compounded annually. At the end of 12 years, he's doubled his money. Okay, to the nearest 100th of a percent, what is his interest rate? Okay, there's 2 ways to do this question. If you're going to use this formula, technically it's not part of 30-1. You need to have it memorized. The intent of this question is actually to use this formula, okay? But I think the majority of teachers teach it going this way. So as long as you're fine with that, but you have to have that formula memorized. Now, it says Joe's doubled his investment. So his accumulated amount is 9,000. His principal was 4,500. His rate is what we're trying to find, compounded annually, and for 12 years, compounded annually. Now all we got to do is just solve for r. So divide both sides by 4,500. And isolating for r, so I'm going to take the 12th root of both sides. So I get the 12th root of 2. And then what I'm going to do is just isolate. So I'm going to go the 12th root of 2 minus 1. And if you take a second to put that in the calculator, we should get something close to 6. And we get, to the nearest 100th, I get 5.95. There it is, friends. Okay. Again, if you're going to use that compound interest formula, which is super powerful, you should know it, but you just have to have it memorized. It will not be given to you. Okay, we're out of exponents and logs. We're into polynomials. So we get 2 or 3 polynomial questions on our diploma. So in order to factor the polynomial p at x, we got this ugly thing here. A student determined we have 0 of x is equal to 3. He then wrote the polynomial as a product of a linear factor and a quadratic factor, and we want the values of a and b. Okay, now I'm going to synthetically divide this thing. We could long divide it. I'm going to synthetically divide. Friends, I also use addition method. So if you use subtraction method, you would do something slightly different. But for addition method, multiply by 9, add 21, add 3 times 2 is 6, 0. So what that tells me is p at x is equal to x minus 3, 3x squared plus 7x plus 2. So what's the value of a and b? Right there. Okay. If you were doing subtraction method, friends, what you would do is use subtraction. People would have a -3 right there. Okay. But I do addition. I think it's a little easier. There's less mistakes to be made because subtraction's when I start seeing mistakes. Okay, let's keep rolling. How are we doing? Another poly question. Sure. Okay, a particular polynomial has the following characteristics. A factor of x plus 2 with a multiplicity of 3. Okay. P at 0 is -24. That's our y int, or our constant term. And a minimum value of -66. The Polynomial function described above with the minimum possible degree is blah, and the leading coefficient is blah. So I look at my answers and I see a minimum degree of 4 or 5. And of course, my leading coefficient has to be positive or negative. All right, what have we got here? Well, what we've got is we've got a factor of x plus 2. So we've got an x-intercept over here. And we've got a y-intercept at negative 24. And it says I've got a minimum value of negative 66. Now, I don't know where that is, but I'm going to start drawing this thing, and then I'm going to figure out where to put this guy. So multiplicity of 3. Well, I'm going to start here, and it changes concavity. There's a point of inflection right there. And then what I'm going to say is, okay, I'm going to go down to negative 66. I'm going to turn back up around, and then I'm going to go right there, like that. And it says minimum degree. So I'm going to say my minimum degree, I'm going to just intersect it. I'm going to make it 1. I'm not going to do that because then that would be a multiplicity of 2, which wouldn't give me a minimum degree. So what I'm going to say is I can draw this exact graph with this down here at negative 66. Degree, multiplicity 3, multiplicity 1. So degree 4. And the leading coefficient's positive because my graph ends going up. Answer A. Okay. I would just say to myself, could I draw that thing? I can draw it with degree 4. So I know it's degree 4. Okay. And there's how I'm going to do that thing. That's a sneaky question. Another polynomial. Okay. What does this one say? Graph of the polynomial has integral x and y intercepts. So it means we don't have decimals, right? 0.5 or 0.2 for our x and y intercepts. And what does it say? We're written in this quatric, a to the x4 all the way down to plus e. And what do we got to find? Oh, we got to find the values of a and e. Okay. So what we're going to do is, remember, when you're building these functions, always do them in factored form first. So a, and I just got to scroll down a touch there. Okay. X plus 1, but right here, that's a multiplicity of 2. And x minus 1 squared, multiplicity of 2. How do I find a? Well, to find a, I'm going to sub in a point. And the point I'm going to sub in is that y-intercept, right? That's easy. So I'm going to sub in 0, 8. So 8 is equal to a, 0 plus 1 squared, 0 minus 1 squared. So that's just going to be a. And x minus, oh, wait a minute. I'm just looking at my graph there. I'm like, oh, wait, I screwed that up, didn't I? That's a negative 2. I'm sure some of you were screaming at me through the screen. So I get a is 2. So what's my function? 2x plus 1 squared, x minus 2 squared. Okay, now, please, we got to find a and e. I know a. A's 2. Don't multiply this whole thing out to get e. E is your constant term. It's your y-intercept. That's e, baby. Right there, it's 8. So our answer for this one will be the value of a is 2, and the value of e, our constant term, is 8. Okay, now we've seen that question on a written before. So just make sure when you're doing that thing, don't forget to find that vertical stretch value of a right here. Okay, something I know for sure it's easy to forget. All right, we should be out of polys, and we are. Okay, what do we got here? We've got the graph of y equals f at x is shown below, and we're going to take the square root of that. And what does it want from us? Wants the domain and the range of our new associated graph, or no, sorry, the domain and the number of invariant points. And that's how they're written. Okay, so remember, friends, when you're taking the square root of a graph, what you're doing is you're taking the square root of the y values only. Okay, you don't do anything to the x values. So what I'm going to do is I'm going to label my invariant points. So my invariant points are when y is equal to 0 and when y is equal to 1. Now, I don't know where 1 is on here, but let's say it's up here somewhere. Let's call that 1. Now, I take the square root of this thing. I can't take the square root of a negative y value. So this is no longer part of my graph. When I take the square root, what I need you to be careful of is right there, that part of the graph, and right here, that part of the graph, when you take the square root of a number between 0 and 1, it actually gets larger. And so it looks like that. So what this region is right here, friends, that region right there, that's where the square root of f at x is greater than or equal to the original function. Okay, I do need you to know that. That's important. Okay, especially if they ask me to draw this by hand on a written question, I'd probably want to label that. Okay, so what's our new domain? Well, our new domain is to the left of a, negative a, including negative a. So I'm going to say x such that x is less than or equal to negative a, comma, or x is greater than or equal to b, comma, x is an element of the reals. I'm just out of room there. And in varying points, I see 4 of them. So that looks like answer A to me. Okay, so there's a lot of stuff in those radical graphs. A lot of little pieces that you might want to kind of go back and think about as you're doing these questions. NR5, friends. Okay, what do we got here? We've got the vertical asymptote of this rational function is defined by this equation. Value of k. Okay, so first thing I'm going to do on any rational function, right, is I'm going to factor. And I get x minus 5, x plus 2. The bottom's a complex trinomial. We need, off to the side here, I'm going to say I need 2 numbers that multiply 4 times negative 18. What's that? Negative 72. I need 2 numbers that add to negative 1. So my 2 numbers are negative 9 and 8. So what am I going to do here? I'm going to go 4x, 1x, and I'm going to say plus 2 minus 9. Now, if you're struggling with complex trinomial factoring, that's something you definitely want to practice before your diploma. You're going to have to do it a couple times. Okay, now what do we have? Well, these two divide out. That's a POD. So you have a POD when x is equal to negative 2. What we want is our vertical asymptote. That's our vertical asymptote. And our vertical asymptote has equation of 9 over 4. What's that? 2.25, I think. There it is. There's the equation of your vertical asymptote. Now, if I wanted to find my POD, all I do is for my POD, I'm just going to write it over here. And again, if this was a written question, I would not write POD. I would write point of discontinuity. No abbreviations, friends. Well, the point of discontinuity is at negative 2 comma something because it's a point. Well, the only place you can sub that in is, in fact, I'm just going to erase this because I'm out of room. I should have written my final function here, my final simplified function. Bad teacher. The only place I can sub negative 2 is into this final form. So if I want to find the y coordinate, I sub it into there. So if I sub it in, I'm just going to squeak it in here. I would get minus 2 minus 5 is minus 7 over 4 times minus 2 is minus 8 minus 17. So my y coordinate would be that. And we get that question a lot, friends, right? I'm actually surprised that this one said the value of the vertical asymptote. Usually I think we get the value of the y coordinate of the POD. All right, so something to be aware of. All right, we're doing good. Look at this. Where are we at now? Question something. Question 14. Holy cow, we're cooking, friends. Okay, what do we got here? The graph of this rational function can be written as g at x is equal to a over x minus b plus c. So the b would be my horizontal translation. So that's my vertical asymptote. The c is my vertical translation. That's my horizontal asymptote. And we'll have to probably find that. A is my guess. And then they give us some random function f at x. And they say the domain of this composed function. Who wrote this nasty question? Okay, first thing I'm going to do is I'm going to rewrite this. Like that. I like to rewrite it like that. And so what that means is I'm going to compose G with F. So I'm going to substitute F into function G. Well, I better go and find what function G is then. All right, this is a nasty question, friends. There's no doubt about it. New do booted. Okay, remember B is our vertical asymptote. So I'm going to say that's x minus 6 because the graph has been translated 6 units, right? And our horizontal translation, sorry, our horizontal asymptote's at 1, so we're vertically translated up 1. Got to find A. Well, to find A, they gave us that other point. So we're going to sub in the point 7, 0. And now we'll be able to find that A value. Well, thankfully, A is just -1. Okay, so now we've got our new function, x minus 6 plus 1. Okay, we did all that work. We haven't even answered the question yet. What does it tell us to do now? We got to do a composition. Holy, right? Holy cow, you're saying to yourself. So h at x is equal to G composed with F. So now we're going to replace x and G at x with this trinomial, right? Like I was saying, oh my goodness, who made this horrible question? So we replace that. And then we've still got the -6 there. So maybe you want to put that in parentheses, +1, pardon me. Come back up here. Holy cow, h at x is equal to, simplify the denominator. So now I'm going to get x squared plus 3x minus 10. And I want the domain of h at x. So once again, I'm going to factor that so that I get my vertical asymptotes. In this case, I have a couple on my composed function. So there's h at x. Pardon me. Now, friends, we want the domain of h at x. So to find the domain of h at x, I'm going to look in two places. I'm going to look at the domain of f at x, and I'm going to look at the domain of h at x. So I look at my input and I look at my final function. I don't look at g. So the domain of f at x, well, that's the reals. So I don't have anything to worry about there because that's a polynomial. X can be anything. Okay, what about h at x? Well, for h at x, I've got two vertical asymptotes. So D. So again, friends, when you're finding the domain of a composed function, you're going to look in two spots, the input and the new composed function. All right, that is a mean question for 1 mark, right? All right, now we're into trig. So a circular carousel has a diameter of 22, and an adult is standing on the outer edge of the spinning carousel. Sure they are, why not, right? They're just hanging out on the carousel. They got nothing better to do. Let's just hang out on carousels all day, right? Then what it says is it says the central angle formed by the adult when the adult travels 10 meters to the nearest degree. So as soon as I see that, what I'm going to say to myself is this is arc length. So I go to my formula sheet, and I always write arc length like this, just because that's how I think it was taught to me 1,000 years ago. And I sub in what I know. Well, the adults traveled 10 meters. Well, that's your arc. We're looking for theta. And the radius, well, it told us the diameter was 22. So that tells me the radius is 11. Now, what I'm going to do from here is solve for theta. So that's 10 over 11. But what I really need you to remember, friends, is when you're doing these, this is in radians right now. That's in rads. So what we need to do is to convert that thing into degrees, right? So let's convert that into degrees. So theta is equal to 10 rads over 11 times 180 degrees over pi rads. And when you do that, right, your rads are gone. You're just in degrees. So you've got 10 times 180 over 11. So you've got 1800 degrees divided by 11. And I go and stick that in my calculator, and I'll get 52 degrees. So the trick to arc length questions, friends, is that you need to remember in your formula here, we're always in radian mode. Okay, where are we at now? Still going to be in trig. And what do we got here? The point T, and they give it to us, is the point at the intersection of the unit circle and the terminal arm drawn in standard position. Okay, well, friends, as soon as I start seeing stuff like that, I'm thinking of, I would on my diploma have my unit circle or my special triangles drawn and written beside me on my scrap paper. That's probably one of the first things I would do as I walk into my exam. And it says if the angle of rotation is changed to become whatever this is, then the coordinates of the point where the terminal arm intersects the unit circle. Okay, now, what are we going to do? Well, the first thing I would do, friends, even though this is in radians, on my diploma, I think it might just be easier to think of this in degrees. So what's that saying? It's saying theta minus 270 degrees. So we got to figure out where that point is. What's this point? Okay, we'll come back to here. Root 3 over 2.5, that means theta's 30 degrees. Okay, so how does that help me? Well, now that I know what theta is, simplify. Okay, now if you've got your unit circle drawn all the way out, you could just rotate backwards, negative 240 degrees. What I'm going to do is I'm going to add 360 to find a coterminal angle that's positive. It's called my principal angle, right? Well, there we go, 120 degrees. Well, now if you got your unit circle drawn out, you can just put your finger on it. That's the point, negative 1/2, root 3 over 2. If you're not a unit circle person, what you're going to say then is your reference angle is 60 degrees, which tells you, the values of your point, and then you would just have to think of Cass law. And 120 would mean over here that sine is positive and cosine's negative. Okay, now we didn't need it on that question at all, friends, but I need you to know two more things that I would write down. The equation of the unit circle is that, and any point on the unit circle is that. Those are two things that I would write on my formula sheet for sure when I walk into my diploma. They come up quite often. Okay, and again, I would take the time because I've got 6 hours if I really want to. I hope you don't spend 6 hours writing this. Rip out my scrap paper, write down, I'm a unit circle guy. I would write down the whole unit circle. If you're a special triangle person, write down your special triangles. Okay, you're going to come back to it several times, might as well. Okay, here's another one. We got some given point where A is greater than 0 is the point of intersection between the terminal arm of angle theta drawn in standard position on the unit circle. And the value of A can be written in this m over root n. Okay, no idea what any of that means, right? Like, what the heck is this question trying to ask me? Well, I don't know, right? So if I don't know, start trying something. Well, what they tell me is I've got this coordinate pair, and it's where A is positive. So where am I drawing this thing? Down here. It's going to be in quadrant 4. I label my sides. And on the unit circle, so my radius or my hypotenuse is 1. Well, it says we want like the value of A. Like, what the heck is A? Well, I'm just going to go back and use my favorite cult leader of all time, right? Pythagoras. And I'm on the unit circle. So look at that. We used Pythagoras, which is Pythagorean, which is the equation of the unit circle. Sub in my values. And all we've got to do here, friends, is isolate for A. And so we get 5a squared is equal to 1. A squared is equal to 1 over 5. A is equal to, well, we take the square root. We really get the positive and negative root of that. But given where we've got this thing drawn, it told us A was positive. So I'm just going to ignore the negative that's extraneous in this question. So the answer of this thing is 1 over 5. 1 over root 5, but 1/5 is how we put it in. Now, do you notice you didn't have to rationalize that thing? Maybe you were told at some point in your life you have to always rationalize denominators. That is a lie. You do not have to rationalize denominators. Okay? Doesn't hurt to, but you do not need to. Okay? I know you've maybe been told to, and you're like, what the heck is this crazy guy telling me? I'm telling you the truth. You do not need to rationalize denominators. All right. What have we got here? More trig. Oh boy. Secant theta is equal to 13 over 12, where here's my domain. I'm in radians. Then the value of cosecant theta is. All right. Well, what does this tell me? Well, it tells me I'm really looking in quadrant 4. And it says secant. Well, secant is hypotenuse over adjacent. And I'm watching my signs there, friends. Okay. And we want cosecant, which is 1 over sine. So we got to find this y value. Now, there's a very common mistake that goes wrong here. And I'm going to make it on purpose. R squared. So again, I sub in my values. And this is a Pythagorean triple, meaning we're going to get ourselves a nice, easy value here. We're going to get ourselves an integer for a value, if you recognize it. So we get y squared is 25. And what I'll see go wrong on a lot of written questions is a lot of students will say, oh, the square root of 25 is 5. And they'll just go, yep, got this bad boy. And they go, yeah, that's 5. And it says, okay, I want cosecant. Well, cosecant is hypotenuse over opposite. And they go, yep, there it is. Easy question. What you really, really, really need to remember for your diploma is that when you take the square root of a value, you get a positive and a negative. Then you need to analyze where you're drawing this thing. It's right there at -5. There we go. Okay, so please, 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 it's little things like that that end up costing students some serious marks when we're in trig all year long. Okay, so just be watching for your signs as you're doing these things. Okay, take a sip of coffee. And what do we got? Angle alpha and beta are drawn in standard position with the point -7, -4 on the terminal arm of angle theta and the point 2, -1 on the terminal arm of angle beta. Determine the exact value of tan alpha plus beta. Oh, goodness gracious. We're going to need your formula sheet. Okay, so hit pause, go find your formula sheet and tell me what tan alpha plus beta is. All right, sorry, friends, I had to hit pause there. I had to get a cough drop, losing my voice. Okay, so we got to go find tan alpha plus beta. So I go to my formula sheet, pull it up, and there it is right there, right? So tan alpha plus beta, 1 minus tan alpha times tan beta. So I'm going to say to myself, that's my formula. Tan alpha, already forgot it, plus tan beta. Tell I'm a little sick. Brain's not firing at full capacity today. Tan beta. Okay, but I don't know what tan alpha and tan beta are. So what I'm going to have to do, or we're going to have to do here then, is we're going to draw out our two angles. So here's alpha. It says alpha is 2, -1. So we're at 2 and -1. So here's our triangle. Okay. And beta, well, what does beta look like? So beta is in quadrant, where are we? Quadrant -, we're in quadrant 3. So that's -7, -4. So what does that tell us? Well, that tells us what tan alpha is. Tan alpha then is opposite over adjacent, y over x. And tan beta is -4/7, so +4/7. And now that we've got that, friends, what we're going to do is just sub in our values here, and let's see what we end up with. And I realize what I just did, friends. Like I told you, I'm not feeling that well, so I got those backwards, didn't I? Bad teacher. So this is actually beta. I would have got that question wrong. I'm sure of it, right? There's beta and there's alpha. Okay, sorry, friends. Caught my mistake, at least as I looked at the points. So now all we got to do is sub in our values and, you know, just take our time. I would pick up my graphing calculator at this point and just sub in my values, sub in the whole thing. I would use that fraction button if I had it. And what you're going to end up getting here is you'll end up getting, what are we going to end up getting? In the numerator, that's going to be positive 1 over 14 divided by, in the denominator, what's that? That's going to be positive. It's going to be 9 over 7. So you've got 1 over 14 times 7 over 9. That sounds like positive 1 over 18. Okay, there you go. So all you got to do on that question is go and find that tangent identity and draw your two triangles, and don't do what I did. Make sure you label those things properly as alpha and beta. Hopefully you're feeling better on the day of your diploma than I am right now, but it is what it is, right? Okay, we're cooking, friends. We're almost at the end. So an amusement park has 2 Ferris wheels. Shouldn't Ferris be capitalized, capital F? Where's the English teacher? That both load passengers at the bottom, 3 meters above ground. Both wheels require 40 seconds to complete 1 revolution. So always make sure you know how many revolutions it's taking. The larger Ferris wheel has a diameter of 25. The smallest has a diameter of 10. The height of the wheel can be modeled by the form, and they're going to write it as cosine, where h of t is height above ground, t is time in seconds, blah, 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 right? The good old Ferris wheel question. The 2 parameters that must be different. All right, well, right off the bat, friends, what I'm going to say to myself, if I can tell, is remember a couple things I need to know. Is I'm always going to start with D in these things. D is the center of the wheel above ground. It's your midline. Well, the first thing I can tell right off the bat is the midline of those 2 things is completely different, right? So I definitely know D is different. A is your amplitude, but in this question with a Ferris wheel, it's the radius of your wheel. So clearly the radius of the wheels are different. B, well, B helps us find the period. And since it tells us the period of these 2 functions is both takes 40 seconds, the B value would actually be the same for both. C, well, C is that horizontal translation as we draw these functions out, okay? The C value for both of these would be the same. They're writing it as a cosine. So we would actually start down here. The C value for the cosine would be the same for both graphs because we're starting at the bottom. So what's different for this one? A and D. The amplitude, the radius is different. The D value, the midline, the median line, but in this case, the center of the wheel above ground. All right, cooking on. Good old Ferris wheel, out of the way. All right, the average temperature of a particular town in Alberta can be represented by the function and where it's signed. And remember, on application questions, friends, we're always in radian mode. Application always in radian mode. The minimum number of months to the nearest 10th of a month it takes for the average temperature of the town to rise from here to here. Oh, this is an interesting question. Okay, what we're going to do, friends, is we're going to graph this thing. Okay, so grab your graphing calculator, and I want you to input that into your graph. I'm going to do the same thing here. So I'm just going to pull up my emulator, if it wants to let me actually pull up my emulator. Always easier said than done sometimes. All right, there's my emulator. I'm going to make sure I'm in degree mode, which I'm in degree mode. I want to be in radian mode is what I meant to say. Always in radian mode. And then I'm going to graph this thing. So our function was 15.8 sine. I like to use my fraction button. Pi over 6 x minus 3 parenthesis, parenthesis, plus 5. Now, before I hit my graph, I'm going to change my limit settings. Okay, X is time in months. Well, X min then should be 0. Time in months, well, over the course of a year, 12, right? Scale 1 is fine. Okay, minimum, that's my minimum temperature. Well, my midline was at 5 and my amplitude was at 15.8. So that means this thing's definitely dipping down into the negatives. Of course it does. We're in Alberta. It's currently negative 20 in Calgary as I'm making this video. And then the maximum temperature, it's going to go up to roughly 21 or something. So I'm going to go to 25. Doesn't have to be perfect. And I'm going to make my scale 5. And there it is. Now, friends, what we wanted to do was the average temperature of the town, how long it takes to rise from 5 to 15 degrees. So we're solving for time. We're solving for X. When we know the Y value, what we're going to do is we're going to sub in those Y values like that. And so we got a temperature of 5 degrees Celsius, temperature of 15 degrees Celsius. And it says, how long does it take to rise from 5 to 15? So what we're looking for here, friends, is we're looking for the time it takes to go from here to here at that time. So we're going to go and find those points of intersection. So second trace. And let's clear my drawing out of the way there. It's kind of in the way. Intersection. Oops, I hit the wrong button. Try that again. Intersection. So I'm just going to get closer to this one here. First curve, second curve, guess who cares, enter. Oh, it gave me that one. It's at 3. Okay, so we got 1 point at 3 months. I'll just be more careful on this one. So I'm going to go up to here. So there's my first curve, and there's my second curve. It's not liking me. Why not? Sure. Why are you really not liking me right here? Come on. Oh, it's really not liking me. So what I'm going to do here is the first one was at 3. I'm just going to go back. I don't know why it's fighting me. It's my emulator. It could do that. I'm just going to go back. I'm just going to go and just draw that one Y value. And let's try that again. So the first time it intersected at 3 months. And of course, it gives me the wrong one. Oh, goodness gracious, eh? Try that one more time. Of course, you had to give me the wrong one. And everybody's watching. Okay, and the other one's at 4.3. So friends, go back to our test. And what have we got now? Well, the first point of intersection, time 1, was at 3 months. Time 2 was at 4.3 months. So how long does it take to go? Well, 4.3 minus 3 is 1.3 months. Okay, so a couple things to remember here, friends. Application questions were always, always, always in radian mode, okay? And you want to graph those things when you're solving for X like that. Don't try to do those questions algebraically. All right, we're almost there, friends. Each of the following trig expressions can be simplified to a numerical value where cos theta can't equal 0, sine theta can't equal 0. So those are just your NPVs. So it's just giving you your NPVs. So we got to find the value of these things. Okay, so we're definitely going to need our formula sheet here. So what they're getting us to do is they're getting us to do really 3 questions in one, aren't they? So what I want to say to myself is I go, okay, tan squared minus secant squared theta. So I go to my formula sheet and I go tan squared minus secant squared. Kind of sounds like that. So tan squared minus secant squared theta is -1. Ah, okay. So I go back to here. And so what we really have then, I'm going to go sideways. That's a value of -2. Okay. Next guy, tan theta cos theta. Maybe I'll switch pen colors. Okay, I like to work in sines and cosines myself. It's one way to do the question. Or you could say to yourself, cos over sine is cotangent, which is really tan theta times 1 over tan theta, which is just going to be 1. There we go. And last one, what do we get for this guy? Well, again, what I'm going to do here is I'm going to convert everything into coses and sines. So cosecant is 1 over sine theta divided by cotangent. Well, cotangent is cos over sine. So I keep simplifying. 1 over cos theta minus 1 over sine theta times sine theta over cos theta. The sine thetas divide out. Well, now, friends, what do you have? We got 1 over cos divided by 1 over cos. Well, or minus 1 over cos. Guess what? That's 0. So if we want to put these things in order, and usually from lowest to highest, which it is here, well, from lowest to highest, then, friends, what do we have? Well, the lowest value is expression 1. Then the next lowest is expression 3, and then expression 2. Okay, so a simplification question, but they snuck 3 simplifications into it. Holy cow, right? Mucho burrito. Why do they do these things to us? All right. Question 21. The non-permissible values of x for the identity. All right. Now, the non-permissible values, that's when we're dividing by 0. So what I'm going to do here is I'm going to rewrite this identity, this possible identity, I guess. I'm going to rewrite it like this. I like to work with coses and sines. Now, make sure for an identity, when you're finding the non-permissible values, you're checking both sides. So what I'm going to do here is I'm going to say sine x can't equal 0. Cosine x can't equal 0. And this one here is as well, cos x can't equal 0, but I've already got that. So that's good news. Okay, sine x can't equal 0. So first what I'm going to do is I'm just going to find where that's non-permissible from 0 to 2 pi. Well, sine is 0 at 0, pi, and 2 pi. Cos x. Well, cos x is when we haven't moved sideways. That's at pi half, 3 pi half. Now, it looks like they've written this thing as a general solution, or I guess we could call it the general anti-solution. I don't know, because it's the non-permissibles. So what you want to do then, friends, is remember you always want to write these things. Think about it like as a picture. And so as a picture, there's 0, pi half, pi, 3 pi half, 2 pi. So I notice the distance from all of my answers, the distance in between them is pi half. So what I'm going to say is x can't equal 0, it's my first value, plus multiples of pi half, n's a member of the integers. If you did a z, that's just fine too. Well, I don't really need the 0, do I, friends? So it's just multiples of n pi half. Answer is C. Okay, so finding the non-permissible values of a trigonometric identity is definitely something you're going to see at some point. Okay, let's keep going. We're almost there. Into perms and columns. Now, as soon as I said we're into perms and columns, some of you probably went, oh, perms and columns, I hate these things. Nah, they're okay on the diploma, friends. They're not bad, okay? So what do we got? For a team photo, we got 9 players, and they're standing in a line. So as soon as they're standing in a line, friends, that's a permutation. Order matters. The photographer is going to put the shortest player at one of the 2 ends and the tallest in the middle. Okay, draw a pretty picture. 6, 7, 8, 9 people. And we're multiplying. So if this was a written question, I would want to show my operations like that. And what do we got here? We've got the tallest persons in the middle. 1, 2, 3, 4, 5. Here's tall E, right? That's never me. So there's only one tall person, or tallest person. But then shorty, well, shortest person could be here, or they could be down at the end. And as soon as I made that word, as soon as I said that word, or, what I want you to think, or means addition. So what I'm actually going to do is say to myself, friend, well, you know what? Or shorty, which is me, is down at the end. So they could be at the start of the line or the end of the line. Okay, so here's shorty again. So I'm going to make two cases. Okay, so in the first case, there's only one short person. In the second case, short person's down there. And then what have we got left? Well, there was 9 people. We've taken away 2. And as I said the word 2, I wrote the word. I wrote 2. I was silly, right? Okay, 6, 5, 4, 3, 2, 1. And down here, tallest person again is going to be in the middle. And 7, 6, 5, 4, 3, 2, 1. So what do we really have, friends? Well, we've really got 7 factorial plus 7 factorial. And 7 factorial is 5,040. So 5,040 times 2 is that. So you just had to watch for the idea that there was cases here that the short person could be in 2 different places. All right, we're almost there. There's only going to be 24 multiple choice questions on your diploma, 8 numeric response. So we're almost there, friends. What do we got here? Circle is drawn with 6 points on the circumference. And we're going to create, students got nothing better to do. They're creating polygons with 3 or more sides. Okay, the key word there's 3 or more. Or means cases. Now they're going to draw polygons. So a triangle is a polygon. Does the order matter in which I drew that triangle? If I started up here at that vertex or down here? No. So this is a combination. How many points on the circumference? Looks like there's 6. How many do I need to draw a triangle? 3. Or I'm going to make something with 4 sides. 6C4. Okay, so order doesn't matter. This is a combination. And that's going to be 20 plus 15. That sounds like 35. And geez, I hope 35 is down here as one of my answers. There it is. Okay, so combination question. Okay, that's the same, friends. Like we get that question a lot. You know, sometimes we get the question with the handshakes sort of idea where combinations, order doesn't matter. Okay, friends, last multiple choice question. There's 24 multiple choice questions. So our diploma only always ends with 1 or 2 binomial theorems. Okay, coefficient in the 9th term in the expansion of this. All right, first thing I'm going to do on my diploma. At this point, friend, on your diploma, you're getting tired. Right? You've been at it for a while, right? And what I want you to think when you get to the binomial theorem, take it slow. These questions are too easy to get wrong. All I want you to do is just write it out. Take your time. So n is my exponent, 10. K, well, friends, if I want the 9th term, that means k is 8. X is 3x. Y is -1. Now what we do is we sub in our values and take your time while you're doing it. Like that. And now all we're going to do is simplify. So this is term 9. 10C8 is 45. Now I'm going to make a mistake here on purpose. Not on this line. Okay, -1 to the power 8 is +1. Okay, I'm going to make a mistake on purpose. I'll see a lot of students do this. They'll write that. Well, what you need to really remember, friends, is that squared applies to everything in the parentheses. So that's really 3 squared. So now what do we have? Well, we've got 45 times 9. Well, 45 times 9 is 405. X squared. We only want the coefficient. And there it is. Now, the question didn't ask for it, friends, but one of the common questions is it talks about how many terms are there in the expansion. Well, what I need you to know is there's 11 terms in the expansion. There's always one more than the highest exponent I see. Okay, so we usually get, at least the last few years on the diploma, we usually get 2 binomial theorems to finish off with. And lo and behold, numeric response number 8 is another binomial theorem. Okay, so I didn't lie to you. Not this time, at least. Okay, 6 statements about the expansion of the binomial are shown below. And we've got to find the 2 that are correct. Okay, were their students correct? And it looks like, kind of looking at the statements, they're kind of look like they're kind of lumped into 2 groups. Right? I see something about the number of terms, and I see something about the largest exponent. So the number of terms, well, I was just talking about that. So if this exponent is n, what that tells me is there's n plus 1 terms. So statement 3 is correct. That's good news. Now, it says the largest exponent. Well, what the heck? Well, how would I figure this out? Because they didn't tell me how many terms there are. There's n plus 1 terms. What I want you to think is you're expanding this thing. If you wanted to expand it all the way, it's going to start with the highest term or the highest exponent, because that's x squared. And that's really x to the negative 1. And as we slowly get larger, friends, the original term, x squared, is only going to get smaller, and x to the negative 1 is going to continue to get raised to bigger and bigger powers. So your largest term is actually your first term. That's when k is 0. So what we do here, they certainly did not leave us a heck of a lot of room to work. So I'm going to scroll down here. Again, I write out my formula, right? It's my last multiple choice question on my diploma. Okay, I start summing stuff in. Well, I know k is 0 because that's going to be the highest term. X was x squared, n minus 0. Y was negative 1 over 2 to the x. K is 0. Okay, I actually don't care about the coefficient. It said the highest term on the exponent. So what I'm going to get here is x to the 2n. And remember, on this last term here, anything to the power 0 is simply just going to be 1. So the highest exponent on the variable of x will be 2n. I go back up here, and that's statement number 4. Okay, friends, there it is. There's the 24 multiple choice, 8 numeric response questions. What I'll do is, this was a long video for sure. I'll make a secondary video where I'll go through the 3 written response questions, and I'll give you some big hints for things to avoid so that you maximize your marks on the written. Okay, I hope that helped, and hopefully the next video for the written helps you out too. See you another time, friends.